We're back with section 18.2 on hydrocarbons. This is one of the more difficult sections, so I would highly recommend making sure you have your notes out and you're paying attention. You see, hydrocarbons are split based on how many bonds there are. If something contains only single bonds, it's called an alkane. Consider the following examples. We're on letter A. CH4, C2H6, C3H8, C4H10. Let's take a look. CH4 is the easy one. I hope you know that the little dashes that I'm making, they're all hydrogens. I just am not drawing them out, being a little lazy. So that's CH4. How about C2H6? Well, C2 means there's two carbons. 1, 2, 3, 4, 5, 6 hydrogens. Let's double check to make sure that's okay. The carbon has 4 bonds. 1, 2, 3, 4. Carbon has 4 bonds. 1, 2, 3, 4. All good. C3H8. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens. Good. And carbons are all good. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And as you can imagine, C4H10 is going to be drawn very similarly. Oops. I need a mouse. 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. Alright, good. Now, what's this formula up here doing? Well, however the number of carbons you have, there are twice as many hydrogens plus 2. So if I was dealing with carbon 51, well, what would the hydrogen be? Hydrogen would be twice 51, which is 102 plus 2. That means it would be 104. Now that is a massive hydrocarbon. Also, let's consider polarity. Now, something that's polar is uneven. Well, if you saw the frame skip, it's because I messed up. I figured that I wouldn't want to have to re-explain myself. I correctly said if it's polar, it's uneven. Now, something that is completely the same on both sides. It's reflective, symmetrical. It's going to be nonpolar. So if I draw a line down the middle, it's the same on both sides. It's nonpolar. We're going to put a big N. Drew down the middle, same on each side, nonpolar. Drew a line down the middle, same on each side, nonpolar. Same thing. Line down the middle, same on each side, nonpolar. Almost all alkanes are nonpolar. Alkenes, one or more double bonds. So if there are like a zillion hydrogens, a zillion carbons, there's one double bond, it's an alkene. Consider the following. C2H4. Well, let's get our pen out. C, double bonded to the carbon, 2H4. Now, I commonly see people make the mistake. It makes my heart sad. People who put triple bond on carbon. Or not triple bond, three hydrogens bonded to a carbon. Oh, I got the dinner call for dinner in 5 minutes. Better finish up the video. Now, if there are 5 bonds on this carbon, it's not good. Because carbon can only have 4 bonds. so don't mess that up. Here I'm going to draw straight across for the C3H6. Well, I have to give at least one double bond. So I can put it in either one. I'm going to put it over here just to change things up. Now I'm going to address the hydrogens. I need 6 hydrogens. 1, 2, 3. This carbon already has 3 bonds. That's its fourth. 4. This carbon has 2 bonds. Needs 4, 5, 6. Good. And then when we get to the general formula here, let's do 51. Just a strange number of carbons again. How many hydrogens would it have? It would have exactly twice as many. 102. Now that principle only applies if there's one double bond. If there's like tons of them, of course the hydrogen count's going to go down. But that's just a general rule if there's one double bond. Let's talk about polarity. Remember, polar is something that is asymmetrical. Nonpolar is something that's symmetrical. Put a line down the middle. Polar or nonpolar? That is nonpolar. It's symmetrical on each side. However, well, that's a bad line down the middle. But take a look. It's different on each side. That means it is polar. This is our first polar molecule we're dealing with, something that is uneven on each side. Thus, it's going to have partial charges. Over here, there's less. There's more hydrogen over here than there is over here, so this side's going to be less positive than this side because hydrogen's more positive atom, etc. Lastly, we deal with alkynes. Alkynes. If we have alkanes, only single bonds. Alkenes, double bonds. Alkynes are triple bonds. So look for the A, E, and Y, the alkynes. General formula is whatever number of carbons there are 2 times minus 2. So if there's, let's do 30 this time. 30 carbons, there's going to be 30 times 2, which is 60 minus 2. It's going to be 58 hydrogens. Example of this is C2H2. It is non-polar because it is the same on each side. And C3H4. I'm going to draw the triple bond on this side. You see this carbon in the middle already has 4 bonds. It's all good. This carbon needs 4. It's got 4 now. This carbon needs 4. It has 3. Give it one more. Now it has what it needs. Of course, you split it down the middle. This is polar. This side has lots more hydrogens than this guy who has 1. And so anyway, that is alkynes. One or more triple bonds. You also have cycloalkanes. Sometimes these alkanes come in a circle. And so you see this little triangle here. It's not meant to confuse anybody. It's not actually a triangle. You would set up carbons in a ring. So there are 3 carbons there. It's an alkane because there's only single bonds. And of course you'd have to put the hydrogens in. And you would have C3H8. So it's an alternative way of doing this regular propane. This cyclopropane is arranged in a circle. It's kind of like an isomer. And then butane, pentane, hexane, heptane, same thing. You're going to draw the carbons in a ring. Hope that makes sense, Stephen. Quick thought. If the compound is known as a saturated compound, it has a max number of hydrogens. If it's known as unsaturated, there's double or triple bonds. So if you go back here to the alkanes. And we're going to draw out, well, actually I'm going to go back. C2H6 is an alkane. Let's take out our pointer. C2H6 is saturated. It has a max amount of hydrogens for the carbon. You can't add another hydrogen here. That's a crime. Now it has 5 bonds. You can't have 5 bonds. You often hear the word saturated used with fats. Do you have too much saturated fats? Getting those Twinkies? Saturated fats, as you should know, are the bad fats for the most part. And that's because the saturated fats are all in a line. All these carbons are in a line, and they have hydrocarbons. Of course, all the hydrogens are in there. And they form a line, and what they do is your arteries, they in your body, they lay down in your arteries, and they kind of camp out, clog your arteries, cause what's called atherosclerosis, where your arteries get hard because of years of plaque buildup of these saturated compounds. But unsaturated fats, like in margarine, butter, have a double bond. And these double bonds actually cause less hydrogen and actually cause like kinks in the chain. And so, anyway, it would actually cause, disregard this here. It actually caused the carbon to go in a different direction. And what happens there is it actually acts in your arteries as like a boomerang. It goes and hits all the rest of the hits the walls of the arteries, doesn't lay down in your arteries, and doesn't cause any hardening of the arteries. So anyway, it relates to biology there. Saturated, every single carbon has a max amount of hydrogens. Unsaturated, there's a double or a triple bond. Nomenclature. We're going to have to do this video in 2 steps because I use the free version of Screencast-O-Matic and it only allows me to record for 15 minutes. So I'm going to have to stop it eventually. Nomenclature. Give the name of the following compound. Let's see. You have meth is 1, eth is 2, prop is 3. Therefore, this is, let me get my pointer out. The prefix is prop. And let's determine if it's alkane, alkene, or alkyne. Only single bonds can be seen. So it's an alkane. Propane. So that's what you use in your gas grills. So step 1 is to look at the number of carbons you have and write down the memorized Latin term. And then discover whether it's an alkane, alkene, or alkyne. Take a look at the bonds. If there's a double bond, it's an alkene. If it's triple bond, it's alkyne. So you have the Latin prefix and the suffix being the alkane, ene, or ine. And of course, if this had a triple bond, let's do a triple bond real quick. And you can kind of think about the carbons or the hydrogens yourself. No hydrogen here. Already has 4 bonds. 1, 2, 3, 4. This would actually be prop because there's 3 carbons, and then Y-N-E, propine. I'm not actually sure what propine makes. I don't know, we can ask Google. Let's see. Propine. Let's see. It's used in gas welding. So that's interesting. And you can see that we correctly drew propine here. Very cool. Oh, it's it's blocked out. All right. Anyway, we're going to come back on the next slide in a different video. So hope that you tune in my next video just a couple seconds.